Hey, how's it going, everybody? We are taking a look today at analyzing graphs of polynomial functions. So if you are in the Unit 4 packet, just keep on going here to the next page right after advanced factoring. Actually, no, right after the fundamental theorem of mathematics, excuse me. You will need a calculator, either download to your Chromebook, download to your phone. I have put in links with apps at the bottom of this lesson in the message part on Google Classroom. So if you need to stop me for a minute and go back and look at those, go find those, but you're going to need one of these for what we're doing here today. Okay, analyzing graphs of polynomial functions, figuring out x-intercepts, which are sometimes also referred to as zeros, and turning points of a function, which also can be referred to as a max or a min. Okay, so we're going to find all this stuff. And what I'm also going to do, again, within the Google Meets link that you found this off of, I also have included a kind of help sheet or a cheat sheet to help you remember how to find these maxes and mins and intercepts. We're going to make note of them here in our paper as well. So, okay, first things first, let's get a graph. So we want to be semi-accurate here. Can't be accurate if I don't graph anything. Hang on here too for a minute. Light's coming on there. Oh, there we go. Okay, that's better. So 3x squared minus 9x plus 1. Okay, so we'll look at the graph. It's a squared, so it should look like a parabola. There it is, okay? But I don't want it to be sloppy. I need some exact values on this. So I am going to pull up my chart. And again, things that can fit, I'm going to go ahead and get onto my graph here. So let's see here, negative 113. Okay, so we're kind of up here. We'll just kind of eyeball that. 0, 1, 1, negative 5. You're like, that's kind of weird. 2, negative 5. 3, 1. And then 4, we're back off the graph again. Okay, so let me get my graph back up. Parabola. And here's why I wanted to do that with you. Notice my last point that I didn't get me the bottom of my graph. It just got me close. Now, how did I know that? Well, I mean, these are the same point. This isn't going to flatline straight across here. So it's getting me a little bit of an idea of what this is going to do. So here's how we're going to figure all this stuff out. We're going to do second and trace will get me to the calculate menu. Okay, this calculate menu is basically the menu we're going to find for everything that we need. So what we're going to do here is we're just going to take a note here off to the edge. So we're always going to do second trace. Then if we want an x-intercept, we're going to do number 2. If we want a max, we're going to do number 4. And if we want a min, we're going to do number 3. Now, there'll be some more directions coming on max and min, but that's going to at least get me a start. So I want a 0. Okay, I want an x-intercept. I want to find these two values, okay, going straight through the x-axis. So to find these, on any of these, here's what you're going to do. Okay, we're going to use left and right arrows only. We're not using up and down at all, just left and right, okay? Otherwise, it's going to screw things up. We're going to get as close to the point as you can. You're like, okay, what do you mean the point? In our case, as close to that x-intercept or that x-axis as we can. That looks about as close as I can get, okay? That's true whether it's a max, a min, an intercept. Doesn't matter. Get as close to that point you're looking for as you can. And then once you get there, we're going to click the left arrow 3 times and hit enter. You're like, okay, why 3 times? Because what I'm trying to do, 1, 2, 3, enter, is I'm setting a border, and I want to make sure I get far enough away from my point, if I wasn't able to get exactly on it, that I can find my value. So you'll see this little arrow there and this little faint line having that border, okay, that bound. Once you do that, this is the end. We're going to go right 6 times, and we're going to hit enter twice. You're like, okay, Hardy, you know you got explaining to do here. Okay, so here's why we're going to do it that way. We're going to do right. There we go, right. 1, 2, 3 gets me back where I started. And then 4, 5, 6, 1 enter sets my second bound. Notice now I have arrows that are pointing at each other. They're kind of trapping in and saying, it's right here, it's here. And then I hit enter one more time for my guess. And the value that I see down below is my intercept. So my x-intercept here would be, let's see, 0.120, because my y value is always 0 on an x-intercept. So I found that first point, but guess what? There's another one. You start the process over. Second trace, number 2. Again, left and right arrows only. Arrow over as close as you can. Ooh, that's pretty good. To that point. Left 3 times. 1, 2, 3, enter. Okay, there's my left boundary. Right, 1, 2, 3, 5, 6, enter. There's my right boundary. Again, there's the arrows pointing in. It's in here. Hit enter one last time, and there is my other 0. 2.880. Okay. So you're like, why are we doing all this again? If we were getting into some of the applications, there's a lot of applications in business with maxes, which mean like be a max profit, min would be a maximum loss, and sometimes an x-intercept can be what's called a break-even point. So even though we don't get into it directly here, it does have an application moving ahead. Now when we get to our max and min, well, now we're experts. Now we're like, okay, so second trace. What do we want to find next? Let's do the min. Oh, let's do the max. That's next. I should go in order. Okay, now you're like, wait a minute, Hardy. So what's going on here? Well, a max would be if we had a parabola opening downward. It'd be the top. I don't have that. So this time, there is no max. Second trace, number 3. And min, the minimum, though, is when we have a parabola opening up and we're looking for the very bottom. That we do have. So again, arrow as close as you can to that minimum. That's pretty good. And that same thing. The rules don't change. 1, 2, 3, enter, left boundary. 1, 2, 3, 4, 5, 6, enter, right boundary. It's in here, enter. So my minimum is at 1.49999, which would be like 1.50, negative 5.75. And that's my min. And again, if I look at the picture, that seems reasonable. Because here's 5, here's 6, and it looks like with my sketch even, it was between 5 and 6. So it's reasonable. So that's how we do mins and maxes. Now increasing, decreasing is a little bit different of an animal. Okay. What we're going to do is we're going to break our graph into parts. Okay. So here's how this works. We're always going to be working with increasing and decreasing from left to right. So if I start here on the left part of my graph and I start tracing it, am I decreasing or increasing? Am I going down or am I going up? Well, I'm going down. And I'm going down until I get to my minimum. So I'm decreasing from negative infinity because with these, we're strictly looking at x values. So this is going forever to the left. If it kept stretching out off the paper and going on, it's going to keep going forever. So negative infinity is where we start. We're always going to start with negative infinity. We're going to end with positive infinity. So we got to cover the whole graph. So from negative infinity to the x value of my minimum, that's what I care about right here. Oops, and I'm writing in the back of my head. There we go. That's all I care about are the x values here. So from negative infinity to 1.5. Okay. Then what happens? Starting when I hit that minimum, I'm increasing and I keep increasing forever. I don't start decreasing again. Now, the question some of you may have at this point is, okay, Hardy, I noticed you put a bracket on this and a parenthesis on this. Why? Because we don't want this to break up. The 1.5 is part of my answer. I can't put brackets on both because if I did, I'm including it twice. Now, could I fight that? I probably could, but if you put a bracket on either of these, you would be correct, is what I'm saying. So if you put a bracket here and a parenthesis there, you're still okay. Might be one of those online issues again, but again, paper and pencil wise, that's what we would do. And that's how we do increasing, decreasing. So if we do it again here for number 2, and these, as you can see, they take a little bit of time, but as you get used to this, it goes a lot faster. So let's do one more, just to kind of see how this goes and how these work. Okay. So this time I look at my graph. This one's going to be, okay, like, oh, that's not bad. Just kind of. So I go to get me some points because I want to be accurate. I also want things that are going to fit on my graph. So let's see here. Let's bump this up a bit so you're not writing through the back of my head. So -1, -9, 0, 0, 1, 9. That's all I get that I'm looking on here. And I'm looking at that and I'm like, well, yeah, that kind of looks like, it kind of. Now, this is a little more interesting because this time I look and I go, okay, well, the x-intercept is like right there. Hardy, that looks like 0, 0. It isn't 0, 0. Here's a clue. Remember, with x-intercepts, y equals 0, if I look at the chart, if I ever see something in the chart that has a y value of 0, that is an x-intercept. I don't have to do the trapping game. Now, would I still get the same answer if I did the trapping game? Sure, and you can do that, but it's not something you have to do. Okay, maximum. Do I see any sort of hump that's going like that? No. Okay. Minimum. Do I see any curves with a bottom? No. Huh. Okay. Now, let the fun begin. Increasing, decreasing. Start from the left, right? And we're going up, we're increasing. So starting at negative infinity, we're increasing. Still increasing. I curved a little, but I didn't start decreasing. Hey, I never stopped increasing. Like it was going up forever. Didn't decrease at all. It happens. That's why we showed you one, just to make sure. So we always can do maxes and mins using the trickery up above, but sometimes we may not need it. So the graph kind of tells us the story that we're going to need. So basically, it's going to be a lot of these. It's going to be a lot of visual and looking more than calculate. So as we flip over, now this one looks like it's going to be nasty and awful, but it's not. So we're still going to put it in our calculator because I want to show you some things. I'm going to do this on our example here to make sure that we don't forget the parentheses. So, oops, it doesn't help if I put a decimal point though, does it? Ah, there we go. So x minus 2, x plus 1, x plus 3. Now, this is going to look a little funkier. There we go. So what do I see? Visually, I see 1, 2, 3 zeros. Okay. Visually, I see a max and I see a min. So I see 5 things that I need. So again, pull your chart. Chart's going to be helpful. Do a little bit of sketching. I am going to actually use the decimally stuff this time just because I want to get a little bit better of an idea of what's happening here. But I noticed something, okay? Since this is factored, now I still can use my trick from before and say, hey, there's a 0 or an intercept, there's a 0, there's a 0. I got all 3, okay? But I also could use the fact that these are factored to know I can set these equal to 0 and use algebra to find the values as well. Same ones I got off the calculator. But remember, these zeros that we're looking for are intercepts. Okay. So I get those. And then again, maxes and mins. We'll do those because we didn't get a whole lot of practice with those on the front. So we're going to do second trace. We're going to find our min first this time. So my min is over here. Again, left and right arrows. It's pretty close as we can get to where that minimum looks like it's at. And then no enters yet. Left arrow. 1, 2, 3. Enter. There's my boundary, my left boundary. 1, 2, 3. 4, 5, 6. Enter. There's my right boundary. And one more enter will get me my min at 0.79, negative 1.64. One last one. Second trace. This time I want a max. So we want this value. Because again, I see the hill. Mins are valleys, maxes are hills. So I get up to the top of the hill. You know the deal at this point. Left. 1, 2, 3. Enter. Right. 1, 2, 3. Back where I started. 4, 5, 6. Enter. And one more for the actual solution, which is negative 2.12. 0.81, and I can get all the values that I need. A lot of button pressing, okay? A lot of techie stuff. Now, the last thing, and we talked a little bit about this when we were finding our zeros with the fundamental theorem. There's this thing called double roots, bounces, multiplicity, okay? What it means is, when we go to graph this, and we'll do that right now, basically what it means is we are going to see a point where our graph goes, hits the x-axis, and then bounces back off. So what you're going to see is you're going to see a couple of them here. There's a bounce, there's a bounce. bounce, bounce. The bottom's in my W here. They hit the x-axis and bounce right back up. And if I look at my chart, those bounces occur at -1 and 3. And so if I use my calculator again to plot the rest of the points, there's my W. There are my intercepts. Okay, it just touches them. It doesn't go through. It just touches them and it doesn't go anywhere. Now, here's how that can help me. When I go to find my maxes and mins now, you might be wondering at this point, do I already know what the mins are? Let's test one out to make sure. Second trace. Okay, let's find a min. Get down here. 1, 2, 3, enter. 1, 2, 3, 4, 5, 6. Enter to set my second boundary, and 1 enter to hit the answer. Ooh, good opportunity for a learning experience here. You're like, Hardy, why are you writing 0? That says 5.18. But you notice how it says E at the end? Anytime you see E on the calculator, E means 0. Because this means 5.18 times 10 to the -11th power, which would in actuality would be 0.00000000005. Now that's really close to 0. So that's why we just write 0 instead of all those decimals. So yes, our mins are both at those intercepts. If I check the first one and that's what I get, that's probably what I'm going to get for both. For my max, again, I think I know what it is, but let's make sure. Oops, I went a little too far. Okay, get to the top. Left, 1, 2, 3, enter. Right, 1, 2, 3, 4, 5, 6, enter. And enter for my guess, 1, 8. So sometimes you can even get your maxes and mins right off the calculator. Okay, so I am now frantically looking for the worksheet for this. I have found it. Okay, so when we're doing the worksheet, sketch the function, state the following. That should say following, not the following. Okay, the zeros, the max and the min. You're like, wait, domain and range. Wait, I don't remember you doing domain and range. Now, stop and think about this for a minute. Okay. Domain is x's from left to right. Range is y from bottom to top. And yes, am I going to do the first one with you? Am I really that nice of a guy? Well, we'll see. End behavior. Okay, we just got done talking about this. This is the one where we have f of x approaches something as x approaches -infinity, and f of x approaches something as x approaches +infinity. So let's say for a moment, okay? Let's say for a moment, actually, I got an idea. I got a really good idea, actually. I'm going to go from here. I'm going to go back to number 3 for a second. We're going to do this other stuff. So domain and range with number 3. Okay, domain, x values left to right. This is continuing to stretch out and go left. Stretch out and go right. Arrows on both ends, infinite. Okay, when there's one going up and one going down, it's going to be infinite. And that's going to be the same for your range as well. Now, if it didn't go down forever, okay? So let's say, for instance, for number 4, you were doing domain and range. Left forever, right forever. You're like, okay. Up forever. Okay. Does it go down forever? Stops right here. What's the y value right here? 0. Okay. So normally you're not going to have a whole lot of extra work. You're just kind of re-looking at what things are doing. Now I do want to do one other thing with you though. I want to do increasing, decreasing on number 3. So we can see this one more time. I think colors are helpful on this. I would absolutely use them. If you have that as an option, I think it helps immensely. So increasing, we start at the left side and we just pay attention. What direction am I going? I'm going up, right? I'm increasing. So from negative infinity, I'm increasing until I get to this maximum right here. And remember, x values only. Negative 2.12. That's where I stop increasing. It's also at that point that I start decreasing. And we talked before about how these can be interchanged, okay? But I start decreasing at that value. And when do I decrease until? Until I get to this minimum. Again, I only care about the x value. And then it stops. You're like, well, wait a minute though. Then, wait, it starts to go back up again. You're right. There's another piece that starts at 0.79 and it increases forever after that. This is just a point of how much attention to detail do you pay, okay? With these on here in this video, I really think you can do the 2 problems on your own. So I'm glad I did not do one of the 2. But if you get stuck on something, shoot me a message. We'll walk through it if we have to. We can absolutely do this. Thanks for sticking with me this time. We'll see you next time.